Now we begin the real work of calculating probabilities for variables that are discrete in nature. We will develop probability density functions appropriate for a variety of situations. By the end of this unit, you will be able to recognize and explain discrete probability density functions and calculate and appropriately apply the proper discrete probability distribution to a variety of probability problems. You will know how to use a combinatorial formula to count subsets in order to apply this tool to the hypergeometric and binomial distributions. Furthermore, you will be able to recognize a Poisson process and a geometric process and calculate probabilities based on these two probability density functions. Before we begin, let's talk about some truly amazing mathematical formulas. Certain mathematical formulas can provide the solution to probability questions we may have about a particular experiment. We have looked at flipping coins and have calculated various probabilities for specific outcomes. There exists, however, mathematical formulas that will allow us to calculate the probability that 10 people will arrive at the drive-through lane in the next 15 minutes, or that it will take 5 minutes or less for them to get their meal and leave. These are called probability density functions, and there are many, many of these. They have been developed over the past centuries. Some we will use today are more than 3 centuries old. These things are truly amazing. Probability density functions have been developed to explain the growth of a bacterium, movements of molecules called Brownian movement, fertility rates and death rates, an important part of the Malthusian view of the future, and much, much more. These mathematical formulas have certain properties. Key among them is that the area under the curves must add to 1. In short, the probability that at least one of the possible outcomes will occur is certainty. We will cover only 4 probability density functions for discrete random variables, and in the upcoming unit, 4 more for continuous random variables. But I encourage you to investigate many others that are used to understand such widely different topics as the rate of spread of an epidemic and the springtime growth of wildflowers in a mountain valley.